Good morning, all. In last lecture we have started with the fundamental concept of retaining wall and its types. We have seen the different types of the retaining wall and their importance. After that, now we're going to start with the next topic, lateral earth pressure. So there are in this topic we will going to see the types of the earth pressure, their importance, their applications, and how to calculate by using the different scientist theory that we're going to see. So lateral earth pressure is the force exerted by the soil mass upon an earth retaining structure such as retaining wall. So it is nothing but the single force where it is being exerted by the retaining wall on a soil surface. So there are two different distinct kinds of the earth pressure. The first one is the active earth pressure. The second one is the passive earth pressure. These are the two types of the earth pressure in detail. We're going to see in detail. After that, first let us consider a retaining wall which holds back mass of the soil. As per the shown in diagram, this was the retaining wall which holds this mass of the soil. When there is a no movement of retaining wall and uh, and the soil mass then pressure exerted by the soil on retaining wall is known as earth pressure at rest. So earth pressure at rest is nothing but the it is the nothing but the when there is no movement of retaining wall. So whatever the pressure exerted by the soil mass on a soil retaining wall by the soil on a retaining wall is known as earth pressure at the rest. So this is what the typical definition of the earth pressure. After that, now let us see what is exactly active pressure. The soil exerts a push against the wall by virtue of its tendency to slip laterally and seek its natural slope or angle of repose, thus making the wall to move slightly away from the backfill. So as shown in diagram, this was the wall move slightly away from the backfill. This kind of pressure is known as active pressure. The soil, being the actuating element, is considered to be active, and hence the name is given as active earth pressure. So this is what the typical definition of active earth pressure. Next, now let us see the typical definition of passive earth pressure, the second type. Let us imagine that in some manner that retaining wall is caused to move towards the soil. In such case, the retaining wall or earth retaining structure is actuating element, and the soil provides the resistance which soil develops in response to movement of the structure towards its called as passive pressure. So more appropriately is nothing but the passive earth resistance, which may be very much greater than the active pressure. So this is what the diagram in diagrammatic way it is has been shown. It is moving towards the soil. This is nothing but the exactly opposite of active earth pressure. So these are the types that we have seen: active pressure, passive pressure, and their earth pressure at rest. Now, important one, in case of active pressure, some fundamental points are there. The structure tends to move away from the soil, causing strains in the soil mass, which in turn mobilize the shearing stresses. So these stresses help to support the soil mass and thus tend to reduce the pressure exerted by the soil against the structure. So in the case of passive pressure, the structure tends to move towards the soil, causing strains in a soil mass, which in turn mobilize the shearing stresses in opposite direction as in active case. So these stresses does not help to support the soil mass and thus tend to increase the pressure exerted by the soil against the structure. So these are the fundamental important points related to this has been shown. Now let us see the next part. The other factors which affect the lateral pressure, such as nature of soil, either it is cohesive or cohesionless. Second is nothing but the porosity. After that, water content and unit weight of the soil. So these are the 4 to 5 factors which affect the lateral earth pressure. So magnitude of the total earth pressure, or to be precise, force of the structure is dependent on the height of the backfill soil. So as a, also and the nature of this pressure distribution along the height. So these are the further information related to earth pressure. Now there are some more definitions or important definitions that will required for the understanding concept of this earth pressure. That is firstly backfill. So backfill is the soil retained by the wall. Okay, what are the soil which is retained by the retaining wall is nothing but the backfill is there. Then active earth pressure coefficient Ka is the ratio between lateral and vertical principal effective stress at the limit stress state where an earth retaining structure moves away by the small amount from the backfill, and along with that passive pressure. Passive pressure Kp is the ratio between the lateral and vertical principal effective stresses at a limiting stress strain when a earth retaining structure is forced against a soil mass. So these are the definitions of active pressure coefficient and passive coefficient. Next, again continuing the gravity retaining wall is a massive concrete wall relying on its mass to resist the lateral force from the retaining soil mass. The flexible retaining wall or sheet pile wall is a long, slender wall relying on a passive resistance and anchors or props for its stability. So, mechanical stabilized earth is a gravity type retaining wall in which soil is reinforced by the thin reinforcing elements such as steel, fabric, fibers, etc. So these are nothing but the further in order to calculate the earth pressure at rest, we're going to see a typical concept. Now, earth pressure at rest may be obtained theoretically from the theory of elasticity applied to an element of soil. Remember that lateral strain of the element is zero because earth pressure is at a rest that we need to calculate. So, referring to the next slide, the principal stresses acting on an element of the soil situated at a depth of z from the surface in a semi-infinite, elastic, homogeneous, and isotropic soil mass are sigma v and sigma h as shown in figure. So we'll show you the figure. So this is not the in a first diagram. Stresses on a element acting on soil at a depth z is given, and second diagram is pressure distribution for the depth eh. Eh is the depth below that. So let us ES and V the modulus of the elasticity and Poisson's ratio of the soil respectively. Now, in order to calculate the earth pressure at a rest, so formula is P0. So pressure P0 is equals to 1 by 2 K0 gamma H square, where K0 is 1 minus sine phi, where phi is the angle of internal friction, where and K0 is the coefficient of earth pressure at rest, where h is the vertical height and gamma is the unit weight. So by using this formula, we can easily calculate this earth pressure. Once we know the value of the angle, we can calculate the K0, that is nothing but the coefficient of earth pressure. After that, unit weight gamma that we can calculate, and h vertical height that if it is known, we can easily calculate the earth pressure at rest. So based on this concept, we will going to see numerical in order to calculate the earth pressure. Let us see the numerical. A rigid retaining wall 6 meter high is restrained from yielding. The backfill consists of cohesionless soil having angle 26 degree and unit weight 19 kilonewton per meter cube. Estimate the total earth pressure per meter length of the wall. So first we will write down the given data. So they have given a height 6 meter h, capital H is the height they have given. Then backfill they have given. So angle is given as 26 degree, angle of internal friction. Unit weight gamma 19 kilonewton per meter cube. These are the given data. What we need to calculate? We need to calculate the total earth pressure P0 per meter length of the wall. So just now we have seen the formula P0. Since the wall is restrained from the yielding, the wall will be subjected to earth pressure. So first we'll write down the given data. Height they are given 6 meter, unit weight gamma 19 kilonewton per meter cube. The formula is P0 equals to 1 by 2 K0 gamma H square, where P0 is nothing but the earth pressure at rest, 1 by 2 is the integer, K0 is nothing but the coefficient they have given, gamma unit weight, H is the height. So K0 coefficient of earth pressure can be calculated by using the Jackie's equation. Jackie is the name of the scientist who has given the formula to calculate the K0. So K0 is 1 minus sine phi. Angle of intersection is 26 degree. So 1 minus sine 26 degree. So by using the calculator, we can easily calculate 0.5616. This was the K0. So this value corresponds to sand in nearly dense state. After that, P0, the total air pressure per meter length of the wall is 1 by 2 K0 gamma H square. So 1 by 2 as it is, K0 value is 0.5616 into unit weight 19 is given, H is a height 6 meters given. So by using calculator, we can easily calculate P0, which is equals to 192.1 kilometer per meter length of the wall. So this was the total air pressure per meter length of the wall calculated as 192.1 kilonewton per meter of the length of the wall. So this is all about the total air pressure at rest. Now in the next segment we can see the formulas for the active and passive air pressure in different condition by using the Rankine's analysis. Thank you.